Hi everyone, this is section 6.5. In geometry, we're going to work with trapezoids and kites. So we are leaving the world of parallelograms and we're going to look at two different quadrilaterals that have some special qualities but are not part of the parallelogram family. Let's start by looking at trapezoids, reviewing their different parts and aspects and definition. By definition, a trapezoid is a quadrilateral with exactly one pair of parallel sides. Can be this way, oriented any way, but only one pair of opposite parallel sides. The two non-parallel sides are called the legs. So this is a leg, this is a leg. The two parallel sides are the bases. So you have two bases. There's a base here and a base here. These are a pair of base angles, and these are another pair of base angles. Not necessarily congruent, but you have two pairs of base angles off of each base. Now, if the two legs are congruent, if these are congruent, then it is an isosceles trapezoid. If it's an isosceles trapezoid, then each pair of base angles are congruent. So this angle and this angle would be congruent. This angle and this angle would be congruent. We're not going to state it, but don't forget, because these two lines are parallel, these consecutive interior angles would also always be supplementary. This is what's special, though, about an isosceles trapezoid, at least one of the things that's special about it. So if I have a trapezoid and a pair of base angles are congruent, automatically it has to be an isosceles trapezoid. Make sure that's in your notes. So the fact that it's an isosceles trapezoid means the base angles are congruent to each other. In other words, these base angles are congruent to themselves, etc. The converse is also true. If I have a trapezoid and a pair of base angles are congruent, then I know it is isosceles. Another thing that's true about isosceles trapezoids is the diagonals are congruent. That's one way that it is like a rectangle. This is not a parallelogram. The diagonals do not bisect each other. But if it's isosceles, and only if it's isosceles, then the diagonals are congruent, which means if I have a trapezoid and the diagonals are congruent, then it will be an isosceles trapezoid. Okay, here's a problem. This, I'm telling you, is an isosceles trapezoid. We are given that angle ABC is 125 degrees, diagonal AC is 7x, and diagonal BD is 4x plus 12, and this angle EDC is labeled 30 degrees. With that information, I want to find all of these measurements. So the first one that I want to find is the measure of angle BAD. BAD, this angle here. Remember, this is isosceles, so the base angles are congruent. If ABC is 125, then BAD is also 125 degrees. Next, I want to find the measure of angle ADC. So ADC is here. Remember, these two lines are parallel, so these two angles would act like same side interior and would have to be supplementary. They'd have to add up to 180. Since this angle is 125, then this angle has to be 55 degrees so that they would be supplementary and add up to 180 degrees, which is lovely. The next angle I want to find is a little less obvious. It's the measure of angle ABD. It's this angle here. That one's trickier, but if you realize these two lines are parallel and BD acts like a transversal, then these two angles would be alternate interior angles. So if this one's 30, then that angle is also 30 degrees. The next one on my list is the measure of angle ACD, this angle, and it would be congruent with its neighbor over here, so it is also 30 degrees. Now the next one, the measure of angle AED. That's this angle here. I'll erase that arrow. This one here is the one I want to find next. If I look at DEC as a triangle, then that angle would be an exterior angle to that triangle, wouldn't it? Do you remember the exterior angle theorem? That exterior angle is equal to the two remote angles added together. Since this is 30 and this is 30, that would have to be 60 degrees. That one was trickier. And then the last one is to find the length of AC. Because this is an isosceles trapezoid, my diagonals are congruent. That means 7x is equal to 4x plus 12, which means 3x equals 12, which means x equals 4. So when I plug in 4 here, 7 times 4, it is 28 units long. That's how you would find that. Here's a rough sketch of another trapezoid that is not isosceles. If you are asked to find the missing two angles, could you find them? We're given that angle D is 34 degrees and angle C is 57 degrees, but what's angle A and angle B? The way to do that is just to remember that these will always be supplementary. Because these two lines are parallel, these are going to be same side interior. So if you take 180 and might subtract 34, you would get 146. So angle A is 146 degrees. And if you take 180 and subtract 57, you get 123. So this one would be 123 degrees. You can take a trapezoid, any shaped trapezoid, it doesn't have to be isosceles, and you can draw a mid-segment. Just like we did in triangles, you can put a mid-segment in a trapezoid by taking the two legs and connecting the midpoint of each of the legs. That's how you would create the mid-segment. If you have a mid-segment in a trapezoid, the mid-segment will always be parallel to both of the bases. So it's also going to be parallel. And its length is the average between the lengths of the two bases. So if I take this length, this base plus that base, divide it in half, that would give me the length of my mid-segment. If this is 12 and this is 8, then this would be 10. 12 plus 8 is 20, half of 20 is 10. That relationship will always be true with a trapezoid, no matter if it's isosceles or not. Okay, let's say you're given a problem like this. Here is a trapezoid. Its mid-segment is MN and its length is 10. Your task is to find the length of PQ and the length of SR. PQ is 4R plus 2 and SR is 2R. How would you find those? So you remember the relationship of a mid-segment. It's the average between these two bases, which means if I add the two bases together and divide in half, I get the length of my mid-segment. So if I take 4R plus 2 plus 2R and I divide that in half, I get 10. Now I solve for R. To get rid of this divided by 2, which is the same as multiplied by 1/2, I'm going to multiply both sides by 2. So that means that these two bases added together would have to equal 20. So 6r plus 2 would equal 20. And when I subtract 2, that means 6r equals 18, which means r is 3. 6 times 3 is 18. If r is equal to 3, r equals 3, then SR is 2 times r, or 6, and PQ is 4 times r, or 12, plus 2, or 14. Is 10, this is how you check, is 10 the average between 6 and 14? And it is. That's how you would use the qualities or the properties of a midsegment of a trapezoid to solve a problem like this. Okay, let's turn our attention now to kites. Here is a very rough sketch of a kite. These two consecutive sides are congruent, and these two consecutive sides are congruent. Opposite sides are not congruent. If you have a kite, the only congruent angles are the angles that are included between the non-congruent sides. These two angles would be congruent in a kite. Also, you have an axis of symmetry that goes right down the middle here. That axis of symmetry would be straight if it was drawn correctly, divides a kite exactly in half. So I have two congruent halves with this axis of symmetry. This diagonal is called the crossbar. So this diagonal is the axis of symmetry. This diagonal is the crossbar. Notice they do not bisect each other. They are not congruent, but they are perpendicular, always. That you can count on. This axis of symmetry, it does bisect this crossbar so that this will be equal to that in length. And it also bisects these two angles here. This one and this one also get bisected by that axis of symmetry. Write these down. If they're in your book, I'm not writing them down, I'm just explaining them to you. Put these qualities in your notebook, these theorems, and put them there so that you will remember. Okay, let's solve a few problems with this kite. Here I have labeled it, and I've labeled the angle XKE to be 55. From that, can you figure out what angle KTE would be? Remember, this axis of symmetry divides it into two congruent halves. So if this is 55, that one should also be 55. Okay, what is the measure of angle TXE? TXE, if you remember, I said that the axis of symmetry and the crossbar, the two diagonals, are always perpendicular. So that angle would be 90 degrees. Okay, I'm asked to find the measure of angle KEX. Remember, this is perpendicular, so it is 90 degrees. So, and I have a right triangle then. So if this is 55, these two have to be complementary or add up to 90. So that angle must be 35 degrees. Now the next one is angle KET. KET, which is all of this here at the bottom. Remember, the axis of symmetry bisects these two angles. So if KEX is 35, then so is the other side, XET, and so the answer is 2 times 35, or 70 degrees. That's the answer for that angle. Let's look at one other problem with kites. Okay, here's kite ABCD, and my task is to find the measure of all 4 angles, and they are all expressions. So how would I do this? So use two pieces of information. First of all, these two, angles D and angle B, are congruent. That's number one. Also, all four angles would add up to be 360. Either one of those methods will work to solve for x. And once you know what x is, then you can plug it in and find all four angles. So you can either say 5 over 2x, or 2.5x minus 41 equals 2x minus 10. Solve for x that way. Or you can add all these together and say that equals 360. That will also work. I decided to use the two opposite congruent angles, B and D. 5 over 2x minus 41 is equal to 2x minus 10. And now let's go ahead and solve that. When I subtract 2x, I get 1/2 x. And when I add 41, I get 31. And that means when I multiply by 2, x would equal 62. Now I can plug that in. This angle is 62 minus 37. This angle is 2 times 62 minus 17. 2 times 62 minus 10, etc. Plug it in and you've got your four angles. So make sure you have in your notebooks all the different properties and qualities of trapezoids and isosceles trapezoids and kites and all their different parts and how they're related to each other, so that if I throw any kind of problem at you, you will be able to apply that knowledge to answer those questions. And I'm going to go ahead and leave this video at this point. Hope this has been a help, and I'll see you guys next time.